Welcome back to Detailed, an original podcast by ARCAT. This is a show where we uncover lessons learned to help you navigate your next project. I'm Cherise Lakeside, Senior Spec Writer at RDH Building Science, and your host. My guests today are Mike McCormick, Vice President of Facilities Management and Development at CalPoly, San Luis Obispo, and David Hart, President and CEO of Steinberg Hart, and three guests today, Roger Krulak, Founder and President of FullStack Modular. Mike is Vice President for Facilities Management and Development, portfolio that includes capital planning, design, construction, inspections, energy and utilities, maintenance, custodial, landscape, fleet, real estate, and sustainability for a campus of over 23,000 students, 6 million square feet, and 10,000 acres. Mike has 40 years of experience in the industry and has been a pioneer in collaborative delivery methods and capital planning. Steinberg Hart is an architecture, interiors, and planning firm with 8 offices and a portfolio spanning higher education, residential, arts, hospitality, government, civic, and commercial markets. Leading with curiosity and passion, David ensures that the firm's values of design, relationships, and change remain central to its practice. Under David's leadership, Steinberg Hart has strengthened its national presence, expanded its reach, and reinforced its mission to shape spaces that enhance communities and improve lives. Roger Krulak is the founder and president of FullStack Modular, an award-winning, pioneering company at the forefront of mid to high-rise modular construction. With an unwavering commitment to innovation and sustainable building practices for over 35 years, Roger's experience in the built world has transformed the construction industry with its progressive approach to design and manufacturing. Driven by his belief that modular construction holds the key to creating sustainable, affordable, and high-quality buildings, he is using advanced technologies to elevate modular construction within the industry. The project we're talking about today is the student housing program at CalPoly, located in San Luis Obispo, California. California Polytechnic State University in San Luis Obispo is confronting a challenge shared by many growing institutions in California. A rapidly rising student population paired with an increasingly constrained local housing market. Nestled in a highly desirable coastal town, the university has limited ability to expand enrollment without adding thousands of new beds on campus, an imperative driven not just by institutional goals, but by the simple fact that the surrounding city cannot absorb additional demand. In response, CalPoly has launched one of the most ambitious student housing initiatives in the state, a program that will deliver 4,200 new beds through a landmark collaboration with FullStack Modular. The effort aims to redefine how campus housing is designed and built, relying on an industrialized construction strategy that promises speed, quality, and long-term affordability. Now, let's get into the details. Welcome back to Detailed. We don't do this very often, to be perfectly honest, but this project has so much to talk about today, so I decided I'd go ahead and let it happen, and we have 3 guests joining us today. Mike McCormick, Vice President of Facilities Management and Development at CalPoly, San Luis Obispo. David Hart, President and CEO of Steinberg Hart, architects on this project. And Roger Krulak, Founder and President of FullStack Modular. Gentlemen, thank you for joining me today. Welcome. How are you?
Doing great.
Everybody good? Well, we had a nice little pre-chat before the show started, so I'm extra interested now to have this conversation. So we're going to get right down to business. I always start with an icebreaker question, just to get us all warmed up and learn something about you. And so today, what I'd like all 3 of you to answer, you may not all 3 be answering every question, but this one I'd like to hear from all of you. I'd like to know, what was your biggest influence when you were a younger person that led you to where you are today? Mike, why don't you start us off?
Okay, thank you. So I guess I would say I grew up in Indiana. And so like almost all kids in Indiana, I played basketball. And in those days in Indiana, Bobby Knight was the coach of Indiana IU, and there was lots of talk about the movie Hoosiers coming out because that's based on a true story in Indiana. And really, what it's taught me is I wasn't the best basketball player, but what it taught me is the power of a team, and the whole ethos around the movie Hoosiers and Bobby Knight was if you work together as a team really effectively, you can overcome all kinds of obstacles. Much better players on the other side, much better, much more funded. But it taught us that if we can create a team, a really high functioning team, we can overcome all those things. So I've spent my whole career really trying to do that in the construction industry, which is not really oriented around that very well. And so that means rethinking contracts, rethinking how we do procurement, rethinking how we make decisions in the process, how we do the design process. All of these things have to kind of be rethought, and I really think it comes from that, upbringing. I would watch Bobby Knight on TV, and I would think about the power of a team.
Oh, I have to say to that, besides the fact we could do a whole episode on the power of a team in this industry, is Go Ducks. I just had sorry. I just had to throw it out there. David, how about you?
I'm going to use a childhood reference as well. I'm going to say free play. And growing up in Austin, Texas, actually outside of Austin, and actually just even beyond the suburbs, I mean, we went out in the woods and we got into trouble. And I don't mean like trouble, like you got spanked trouble. I mean, that was real, but we got ourselves into some binds, into real trouble, and had to get ourselves out of trouble. And I think that time of being able to just go out and explore and do and find our way, I think that was, I look back and I think that was really great for me and for my development. Um, and yeah, I think about that as I get myself into binds from time to time and have to creatively work my way out. And that's probably my contribution that I find to teams is being a problem solver.
I'm not telling any stories about getting into trouble when I was younger. How about you, Roger?
Yeah, so I think from an influence perspective, I think probably one of my biggest influences was that my grandfather was an innovator. He was always ahead of his time, looking for solutions that didn't exist, and trying to solve for them. And so that it was a huge influence in what I did in my life. I grew up in Cleveland, Ohio, so I spent a lot of time around construction people and the building trade. So sort of the way that the people interface with each other and find solutions and try to eliminate inefficiencies in time has been something that I've been exposed to and thinking about for a long time.
Remind me to tell you after we're done recording the story about me having to wear an Ohio State t-shirt in a lost bet on a stage receiving an award. I'm sorry, any school that's got a nut for a mascot's got a problem. I just have to say. So we now know I'm a sports fan. So let's talk about this project. There is so much to unpack here that I don't even know how we're going to get through all these questions. But let's start with some background. What did CalPoly need, and what led to the decision to take the modular construction route for this project?
Let me jump in and just talk about a little bit of what drives the need for housing first. And so at Cal Poly, we are fortunate enough to find ourselves in a position where we're turning away upwards of 40,000 students that are qualified to get into Cal Poly just because we simply can't accommodate that. And as a state institution, that's not really what we're trying to do. It's bad for California that we're not able to do that. So we're trying to grow our enrollment slowly without sacrificing any of the kind of learn by doing that makes it so popular. But in order to do that, we have to look at housing because we also are in a little tiny city that everybody else wants to live in too. And so our vacancy rate in the community is, less than 2%, which is effectively nothing. And so for us to grow the student body, we have to house them on campus. And we also know, by the way, that students do much better. They're much more likely to succeed if they live on campus. And so we have a need to accommodate all the growth and as many students as we can to live on campus. So we kind of looked at our financial model. And we said we can probably do about 4,000 beds on campus. We can probably support that financially. And so then we have to look at, okay, what's the best way to do that? That's about $1 billion worth of construction. And again, back to our little tiny town that we live in, to find enough contractors to simply do that is really, really difficult in a little tiny town, because we have $500 million of other construction happening on campus already. So we've pretty much already taken up the workforce. So we had to find a way to do this work without importing, a bunch of workers that then have to live in the community, which exacerbates the problem that we're trying to solve, right? And so that's how we kind of focused on doing offsite construction. The other thing that we really hope to do is, with 4,000 units, we really hope to start to see some economies of scale and to drive down the cost of student housing. It's the biggest cost that students have. It's a higher cost than tuition is right now. And so we need to find ways to add the student housing without, increasing the costs of the students and their ability to come to a CalPoly.
Makes sense. David, maybe this one is for you, but give me a broad description of the entire scope of this building, this project.
Sure. So it's really a program rather than just a project. So it's made up of a series of buildings. And as a program, it means that we're measuring our ability to build new beds, design and build new beds against our pro forma, so our financial model. And we are currently modeling around 3,600 new beds, which is right now all planned for being modular. That is using modular construction for all the new beds, looking at 3,600. And then we have another 1,200 beds of renovation on 6 old mid-century buildings that are still doing a good job for the campus for first years. And what we're building is really for second year students and up. And so that's kind of the overall. And all told, I think we are at 22 acres, including the land where we're doing the renovation. So it's about 12 to 14 acres of new development, and about 6 to 8 acres. I can't remember the exact amounts, but adds up to about 22 acres for the overall project, or overall program, which is planned to be implemented over about a 8 to 10 year period. And we're about 2 years into that. And we're not able to take any beds offline through the course of the project because we have to keep that revenue stream going and keep, as Mike was talking about, we need the beds so that CalPoly can continue to grow its enrollment and serve the need that Mike talked about.
So I spotted this in either my trolling of the project online or the materials that you sent me, where you call this and I know what this means, but I'm going to let you tell me. You call this the DMC approach. Explain that to me.
So I think I could probably take that. The DMC is design, manufacture, construct. So the idea is that, seamlessly, CalPoly as owner, Steinberg, Hart as designer, and FullStack as manufacturer are creating an integrated product that delivers what it is that Mike and CalPoly are trying to do. in a way that is effective for the program that David just described.
So I think that's a good lead into the next question. So I understand these units, and I'm not kidding. We could have like 4 hours of interviews about this project with the questions I have. So this is going to kill me. These units are going to be manufactured off-site. And I think I've only done 1 or 2 other interviews for something along these lines. And I certainly have never actually worked on that. Tell me what that looks like. I mean, would you go build this Lego box and then pop it into place?
If I can start, I'm sure if anybody wants to add, I think that'd be great. But let me just start in the basics. So the interesting thing about building offsite, which I think is the correct term, is that the scope of what's happening on site and what's happening offsite can vary greatly. And as Mike described in his program earlier, the goal here, because of the lack of trades and even a place for the trades to stay, the idea is to make as much of the building, and in our case, sort of volumetrically, facade on, finishes done to the extent possible. And in order to do that, a number of things are required. The design has to match an opportunity to finish as much as possible. The program has to match that, and then obviously the pieces and parts, the sub-assemblies like facade, for example, that go into it, all have to be compatible with the idea of delivering as much finished as possible. And so the DMC, the D side of the DMC is, how do we get this to look the way that CalPoly expects it to be? And David Hart's team can make it look, in the beautiful pictures behind. And then how do we take that scope and, to the extent possible, move it offsite?
So I have been actually fortunate in my career to have worked on public work for probably about 25 years of my career. So I am where the 2 firms I worked at were exclusively public work. So I'm very intimately familiar with public work. And organizing with public agencies and public clients and everything that goes into the contract documents, all of those things. So one thing that I was finding challenging to wrap my brain around when I was reading the description and everything is I also know what needs to happen in a design firm to get a building done. So I'm really curious, when you are building part of this building elsewhere and you have people on site building what needs to be in place to bring all of that together, how does the process for a building like this differ from designing a traditional stick-built building? A 100 things pop into my head that have to be like rock solid in the building before these units start coming in, I'm guessing. So what does that process look like when you've got kind of 2 sets of construction going on at the same time?
David, you wanna start with a conversation about how that works, and then I can obviously answer.
Sure. Yeah. So I think the immediacy, what's interesting about designing for manufacturing is that your design is moving into production very quickly. So you're moving from that gap where normally you would have some mobilization, there's buyout, there's shop drawings, there's multiple reviews of the shop drawing, all of the process that we're familiar with. That takes a long time. This process is collapsed, and we are going from design thinking to manufacturing very quickly. The other thing is it's a fully integrated team. Roger's team and our team and Mike's team, and then the contractor, Whiting Turner, are all working in sync with each other to do it once. So the lean principles, basically, to do it one time. And not everything works perfectly, particularly on the first building, but everybody's mindset is towards, we're going to get this right, and then we're going to repeat the repeatable elements of the building, over and over again, and not go through what I would call just the traditional process of design, revisit, rethink, design, revisit, rethink. And because it, it, you can't rethink it, it's been built by now, and then it's on a truck, and then it's being shipped to the site. So it's very gratifying for those of us who've been working in design build for a long time, which is quite popular in California, where we're working in an integrated way with the builder. This is really taking it a step further because we're working with the manufacturer and are in fact integrated with the manufacturer's team. So it's it is different, and I think but I think it's going to save time and eventually save money, and certainly it's safer. There's a whole lot of benefits to this particular process.
Roger, before you talk more about what happens in the factory, what are you familiar with I think it's called the McCleany curve, and it's a graph that shows that the effort that we put in and the value that it brings to the project is better if we shift it left on the graph. So it pushes a bunch of decisions, it pushes a bunch of effort to the beginning of the project. And I think this is really encapsulates that, because as David said, we have to decide on really small details early in the process, rather than trying to do that at the end, where we're actually not bringing a ton of value to the project when we do it late like that. But Roger, why don't you talk about what happens in the factory? Because that's also super
Yeah. I
important.
mean, I think one of the important things about what David said is that, we have a system that allows buildings to be built, although that system is flexible and has design opportunity, etc. It also asks the design team to do something which is unusual, which is to share agency with the system. And that process of the integration that David mentioned is the value opportunity. And as Mike described, it's also the strain, right? Because so much has to be just lumped into the beginning of that process so that we can get economies of scale, achieve the design intent, make sure the use is proper, and then what are the pieces and parts that are going into that in order to give you a finished building so we can get things cranking in the factory. So all of those things happen at the same time, from Mike's comment about the curve. And we're asking the architects to say, hey, just think about the way these things go together, because there's a value proposition with organizing the system in a way that's efficient.
So I'm already going down my first rabbit hole. Mike, I have to ask you, like I said, I have done contract documents for public projects for a lot of years. And I've always joked, no offense, please don't take it personally, that doing projects in California is like doing projects on Mars, because there's just so many requirements in so many places and sometimes so many levels of requirements. What was so is it integrated project delivery? Is that what you call this? And how did you procure it and stay within the public contracting laws?
Well, technically, this is a design build contract, and that's the
Okay.
statute that we're operating under. Now, the terms of the design build contract will look exactly like an IPD project. And so what we created a contract that provides a framework for the entire program that David was talking about, and then we peel off project work authorizations within that overall contract framework for each building. And so so then that provides us with a contractual structure, and then from a procurement perspective, we procured it with that in mind, because we're going through one procurement process and for the entire program, yet you're not guaranteed to have the next project. That's always a decision that we all get to make, right? Because interest rates could skyrocket and we might have to stop the whole thing, or somebody doesn't perform well or whatever. And so because we were able to procure the entire program, we did it completely on value-based decisions. So nobody's bidding. And we did that all the way down through the subcontractors for the entire program. And really all we're looking at is the overhead and profit rates, because that's all you can talk about at that point, because there's no project that has been defined. In terms of the IPD process, this is built just like an IPD contract, so that there are, I think, 12 risk reward partners that put their profit at risk based on the success of the project, of the overall project. And so that was pretty clearly articulated in the framework document, so everybody kind of knows what they're getting into there. And so that's kind of how we did that. It took us a full year to work through the contracts and the procurement process before we launched this, because we knew with this scale of project, we knew we needed to do something different if we were going to do this kind of scale of project and also still try to drive the cost down. So we really wanted to approach it from a process perspective and spent the time up front.
My day job, I'm a spec writer, and I'm getting hives just listening to you talk about it. Yeah. And I'm very well versed in public work. I'm just like, oh, I bet that was some fun front end documents to write. I just had to ask that. I was curious. So let's get a little bit more technical. What needs to be done on the site with the existing building to prepare for these units getting to the site by helicopter or however the heck they get to the site? What do you have to do on site and have locked down before you can start bringing that in?
The way that our system is organized, you can pretty much build whatever you want that can structurally accept whatever the mass of our mods are and how they're connected. And there is a very specific system that allows that foundation, whatever type it is, to interface with the mods starting at the floor that they're attaching to. So that system requires just that there is a theoretical XYZ alignment at the point that the foundation or whatever's happening ahead of time, podium, etc., to receive the mods. And then once that's done, you can stack them. But the interface is very organized and specific to what is needed in order to get there. And obviously the interesting thing is, because we're building in a factory, and this is going to be geeky for you, because we're building a factory, we are building in the factory on a theoretical basis, right? Because we're actually not building on site. We're building in a factory that is supposed to approximate the drawings, which are theoretical, which David created, and then we turned it design for manufacture drawings. So everything ultimately has to meet theoretical for the mod manufacturing offsite to really work. In contrast, if you have a conventional building, you don't have to exactly meet theoretical, except for to whatever tolerance you're willing to accept in order to make it all to go together.
Well, and the tolerance is quite tight. I think Roger's leaving out the precision that is in this process. These are steel mods, and they're coming with facade attached. And so the tolerance of a facade panel to facade panel on any building that would say have a panelized facade system, that tolerance is quite tight. And so we're dealing with placing large semi-sized boxes down with the same level of precision that we would place facade panels. So it's a very precise process compared to wood modular or other sort of, I'll call them Lego block or panelized prefabricated systems. So it is a tight tolerance system.
I'll give an example. So as we're doing all of the utility work and all the foundation work, the contractor has a geospatial monitor that they put down, and so it's a three-dimensional laser scan to make sure that every anchor bolt is exactly the right place, and every receiver for the mods is in exactly the right space, and it has to be exact, to David's point. And so that we had to do a lot of moving things around because of that. But if we hadn't done that, we wouldn't be able to place the modules when they come on site.
One of the things you said really early in this interview that threw me, and it threw me because I now work for a building enclosure consultant. And what I did not expect you to say was that the facade was already attached. Because the handful of projects I've talked about like this, the facade went on after the units were in place. And so that threw me through a loop. So we're skipping right ahead for a minute to the building exterior of this project. And I'm going to actually combine them a little bit. So I want to know how you piece these units together. And I want to hear more about what this building exterior is, the materials, and how you made this a tight building. Because I mean, that's all we think about now working for an enclosure consultant is that tight, energy efficient, no water gets in, no air gets in, no heat gets out. And my mind is blown right now. So I need somebody to explain how this works for me.
I mean, I can just start with, I think David already said, the dimensionality, for the reasons you just described, is this where it starts. It's not where it ends, but it's where it starts. So not every system that goes into the building has the same tolerance. There's no, this tolerance for plumbing and this tolerance for concrete and this tolerance for, it's all the same tolerances. Because of what you just said, that's the reason. And of course, one of the major tolerance requirements is the envelope. How do you make sure that it is sustainably correct and also watertight? And then so our metrology system in the factory drives all of those things. At the same time, we have to put a designed facade on it, and that's sort of where the architect comes in. Is what does that designed facade look like, feel like, respond to, act like, etc. So David can tell a little bit more about that.
So the facade is it's an EFIS system, and it's built up the entire wall component. So you've got the metal studs, and then you have the framing for the EFIS system. It is not a soft foam though, because it has a like concrete, but it's basically a ceramic type finish on either side of that insulated panel. So it's really hard finish. And then it has a nice, attractive drive-it finish troweled over the face of that. Those are manufactured in a shop not too far away from where the mods are, and then they're shipped over to the factory in Carson, where the FullStack Modular is, and then they're placed onto and attached onto the facade, onto the mod. The facade is attached onto the mod into the factory, and then it's shipped out to the field. It's all wrapped, it's wrapped up in plastic, and then it gets craned into place and put down into that precise location. Then there's a brand name for it, but like an M seal that's peeled away, that then is one layer of seal, and then there will be a cosmetic then backer rod and sealant that goes over it's more than cosmetic, but you basically have a double seal. There are other ways to do that with compression gaskets and other approaches, but this one is a little bit of belt and suspenders approach, and it has some control of the cosmetics at the end for that second seal that we are able to do.
And what about insulation?
And so the insulation is in that SIP panel, so that EFIS piece actually has a rigid insulation of it's about 3 inches actually. It's like about 3-inch insulated piece. So you've got that insulated panel on the outside there.
And just to make it a little more difficult than just the weather, we're also in a high hazard fire zone because we're right at the edge of the campus, right up against the wilderness. So we had the facade has to withstand that as well.
You're just not going to do anything the easy way, right? So I am not reading my emails when I look to the side. I have your pictures, the renderings open to my left, and I'm looking at this, and I don't see modular.
Good.
Which and I'm not saying modular construction is a bad thing, but it's not always the from some of the projects I've seen, the warmest, prettiest kind of construction, very functional in a lot of ways. But I'm looking at this and I'm like, somebody explain this to me, because I don't see the pieces. I'd love to see. I'm going to California in next June for the AIA conference. I may have to find my way over here to see this school.
Well, because the joints, Cherise, the joints aren't much different, I should say, than you might see in a panelized facade system. And then we've done some things with the geometry to obscure those seams with shade and shadow and some dimensionality. We did have people who wanted to make it flat to save a few dollars. Mike McCormick said absolutely not. Because I think that's one of the challenges is we still have to make really beautiful buildings, and we don't want to have an asterisk next to it say it's a nice looking building for modular. I think this whole team's goal is to develop a new standard, and that new standard then would have to compete with all the other types of construction. And so, yeah, sorry, you didn't ask a question. I'm just volunteering.
No. Well, it was a great call, because most modular projects have that asterisk. It's great for modular. And I do think that there is a ton of potential benefits. We have a housing crisis in Oregon as well. And anywhere, especially with rising costs and all the craziness going on in our world, anywhere that we can build something that's really great and still look beautiful is always going to be a win in my book. So I also spent 6.5 years working for MEP consultants. I've been around a little bit in the industry. So I've done my fair share of writing specs for MEP systems. How do you plan for that? I know it's always a challenge on any project, having enough space in the ceiling or enough space in the walls, or where does that happen in a project like this?
To the extent possible, it happens in a place that's easily accessible, and possibly, as close to the hallway as possible and as unitary as possible. And that's as possible because there's a wide range of things that work depending on the product and the environment and the time and the desire. So it's hard to say, this or that. But the idea that one of the major sort of parameters that I mentioned earlier is you want it as close to the hallway as possible. You want it as vertical as possible. You want it as unitized as possible, and still meet the MEP or electrical design needs that are required.
So is any of that actually done in the pods before it comes?
Yeah, it's to the extent possible as distributed as possible.
Wow.
And as coordinated as possible. And that varies, item per item. And we could spend lots of time talking about each one of them. But in general, the idea is to do as much as we can. So the vertical risers for plumbing, for example, are done, and what we call mate line kits are shipped with it to do that, for example. But there are some electrical pieces that are sort of a little bit more done in the field because it doesn't make sense to do all of those segments. But and on and on and on. But the idea is you have a lot of flexibility in type of system, but if you want to move the work offsite, it needs to be more unitary and more organized to a place that you have access, which hopefully is mostly in the hallway.
We're actually really excited about that from a maintenance perspective, right? So what that ends up doing is it ends up creating a building that's much more maintainable. And so where all of the verticals connect, that's in the corridors. We have a panel that we can pop off. We can get to all those connections. The HVAC unit is in the rooms. And we even did a little drill that's a ceiling mounted. And so we even did a little drill. It's like, here's a lift. We have four bolts to unscrew. They can take the unit down. They can take it out in the hallway. They can put a new unit in. And we timed it just like a NASCAR pit stop, right? And so our maintenance guys are comfortable that they can get in and out of there very quickly. And that's the kind of thing that we wouldn't have thought about in traditional construction, I think.
Well, I think public, especially public agencies of any kind, really do. I mean, you're not just building a building to sell it.
Right.
You're building a building that you're going to have to live in and maintain, and we all know the cost of that life cycle of keeping a building up is where you're really going to spend your money over the long term. So you want those things are so important, and a lot of people in this industry don't always think about living and breathing and fixing that building down the road. They will, everybody does to a certain degree, but not really thinking about those long-term costs, which are critically important in public work. Because it's my tax dollars in Oregon paying that. I'd like them to be used efficiently. So tell me what the design of a unit typically looks like. Are there a bunch of different floor plans or layouts of these units? Are they all exactly the same? What's in this unit? If I walked in, make me see it.
Well, it's you walk in if you come off of the hallway and into the unit, you come into a small living space, and in front of you is three bedrooms, and then you have a bathroom to your right and a bathroom to your left, and each bathroom has a sink, a shower, and a toilet. So the living space is a little bit of a transitional space for students, but there is enough room to be able to get a small couch and a television or a few study desks. There's a little bit of flexibility about how that space is used. And then once you get into the room, it's designed for the ability to have the baseline is 2 beds in each one. So you've got 6 people living in this unit. There is the ability to add a third bed to the rooms for periods of surge, like there's a big incoming class, or we need more this semester or this year. So there's ability to accommodate that physically, but it's really designed for 6 students to live in that unit together.
What about common spaces in a, I mean, I've had my experience with my kids going through college, and I know what it's like and how they live. What about common spaces in the building? Because obviously the unit's not that big for 6 people living in it. So I imagine the building has other amenities to get them out of the room.
It does. Every floor has a series of study spaces, and then it has a common space with a community kitchen. So every floor gets its own community space with its own community kitchen. And then down on the ground floor, there is a much larger space for everyone in the building, which is a larger social space that has some gaming areas. And then, of course, the laundry. One of the big things that it's the big equalizer for students in their freshman or sophomore year is laundry, and that's adjacent to that big common space down the ground floor. And then we are in an area with a wonderful climate, so that large space on the ground floor has sliding, I was going to say nano wall. I guess for this audience, they'll know what that is, right? So some really nice indoor-outdoor space to take advantage of the wonderful climate that's along the Central Coast there.
College students do laundry? My son always brought his home.
The ones that are dating, I understand, do laundry, but that's just what I've heard.
Makes sense.
Yeah, I guess all of this is designed around community sizes, right? So there's a community size on a per floor basis. There's a community size on a building basis. There's going to be a community size for the whole neighborhood. And so I think David's crew has done a fantastic job of designing community spaces for all of those various sizes of community, so that the students will find a place to belong.
So I'm proud of on the West Coast that we're leaders in sustainability for the entire country, all up and down the West Coast. Were there any particular sustainability goals for this project?
Do you want to go? I can go. I feel like I'm monopolizing.
No, we have all of our projects are designed to a LEED Gold standard as just a pure LEED standard, and then we are dealing with kind of some pretty significant infrastructures on an interesting basis based on the project itself. So the project will go in. It prompted us to consider recycled water. So we're going to be recycling all of our sewage and using that for irrigation, and that takes our water usage down by more than 30%. We have a huge solar array going up because of in part to help power the housing projects, and we're also ended up doing a big water infrastructure project that allows us to take our water at a much more steady pace, rather than kind of the kind of surges that would typically occur in a place like this. So there's a lot of the infrastructure that we emphasize on top of the LEED Gold.
Don't make the rest of us look bad or anything.
The other thing I'll add is just that modular is inherently efficient as it relates to low waste, because you're ordering a whole bunch of materials and then deciding, and cutting them as you go. So there's a lot of you could just, when you visit the factory, you already see that it's a low waste environment. So that is, I don't know that we get as many lead points for that, but it certainly is an important part of the process.
And truck traffic's about 70% down from conventional once you get past foundation. So that obviously truck traffic, et cetera, which is a big deal, especially where we're talking about, also has value.
So from a design perspective, we'll start with design. What would you say was the most difficult challenge to work out for this project in this type of building? And tell me how you navigated it.
Well, I don't know that it was difficult I guess it is. With this project, when you're doing what we would call the room data sheets during programming, here, because we're putting all of the mechanical, electrical, we're solving all of that for the modular design with Roger. And so our room data sheets are down to the 16th of an inch. They're actually working drawings. They're not something that gets approved by the owner and then gets worked out down the way. So if you think about it, this unit that's being developed is going to be moving straight into manufacturing, but also then the owner approval. So the challenge is really around you're sitting and looking at something once, maybe twice, third times, it's set. And in a normal design process, you have lots of opportunity to revisit and rethink and sort of, what else would be nice? And sort of a feature ad, I'll call it. You really don't have that here. So I think one of the big challenges with going in this direction is getting the owner to understand that this, yes, it may only be the fourth time you've seen us in a meeting, but this is it. We're going to be locking this down. And I think that is something that we all work together on. But I would say that for me anyway, as in the architect's seat, I saw that as a bigger challenge than, say, doing what was needed for Roger and his team. To me, I understood that path. It was how do we get the owner to understand that this is a final decision, because it normally isn't at an early schematic / programming stage.
I'll talk about that one
You
in
want
a
to
minute.
add on to that?
Oh yeah, I'll talk about that one in a minute, but because we're definitely our own worst enemy in a lot of times. But I would also say that there was a pretty significant permitting challenge. When the construction is done offsite, there's a different jurisdictions. We have an Office of Fire Safety within the CSU, and then the state fire marshal is at the end, the one that inspects it and says we can occupy it. And this is something they hadn't seen, right? And so we had to work through, spent over a year again, working through who has jurisdiction and what has to be shown on the drawings, and we did a lot of fire testing of assemblies because people hadn't seen that, and so I think that was we knew that was coming, but that was even bigger challenge I think than we expected.
I have a number of friends who are architects in California, and I know one had to wait 18 months for a permit for an ADU. So I can't even imagine how you managed to get all this through in a year. But I'm glad you brought that up, because I usually ask about that process and there were so many questions. It's like, I don't know if I can fit that one in.
Yeah. The AHJ conversation, as Mike mentioned, is very complicated because if the local jurisdiction isn't familiar, and there are multitudes of who's in charge of permitting, who's in charge of inspection, and the fact that you take the HCD, Housing Community Development, and move all the mods out, then they all have to figure out a way to come back together, and that is very complicated. Unless they've done it before and then they don't think about it again. But this was new for them, really. So it's a brand new learning curve.
Has construction, I know when I first wrote, we had a little bit of a delay in actually having this podcast. So when I first wrote this script, the construction hadn't started yet. Has it started now? So and Roger, I think this one would probably be a good one for you. What are the critical things that the whole team needs to be thinking about and considering as you're working your way through the process for construction to go smoothly?
Yeah, I mean, I think we've talked about them a lot. It's really the precursor more than anything. Like, organizing what's going to happen, where, how, and when. Combining a construction schedule with a manufacturing schedule, making sure that everything is happening congruently in a way that allows you to take advantages of the time savings and the economies of scale, requires all those things up front. If those are all done up front, there's not a lot of sweat. If something is missed, and inevitably something's missed, but if something's missed, that's where the energy gets put as to how do we solve this problem, because of the congruence between manufacturing and construction.
I think one of the really great opportunities on this is it requires us to manage flow of the work in a way that you don't do in a traditional construction process. You just don't have to in a normal construction process. But as the modules are coming out of the factory, they get on a truck, they come up here. They only have so much room to store them up on site before they get placed into the building. And so that whole flow, to Roger's point, it takes a lot of pre-planning and a lot of eyes on it throughout the process. And I think that's good for the industry. Actually, we would all learn a lot from that. Managing the flow. Our scheduling software is not set up for that. Our processes aren't set up for that. Nobody really is in charge of the flow of materials in the way that we need it to be on a project like this.
So let's talk about that for a second. On any public project, there's a lot of cooks in the kitchen. This one is a whole completely different animal. You've got a lot of players here. You've got a lot of people on board from the beginning. And you're moving very fast. We're not going through the typical design process where you have time to make these decisions, change your mind, move things around. What are your best practices? What were your best practices to keep this moving as quickly as it sounds like it was moving, and decisions being made and keeping everybody in the loop so you didn't have a unit show up that doesn't fit? How did you manage that size of a team in that communication process?
I want to first start with the contract again, because I think we come back to the contract. And again, 12 parties profit is at risk of this going well, right? And so everybody has a high need to make sure that we're doing this as efficiently as possible, right? And so when you get that kind of motivation behind everybody, the next thing you do is just have to set some structure up, right? And so there's a whole series of meetings. The project management team meets on a daily basis. The senior management team meets on a weekly basis. There's an executive committee that makes decisions on a monthly basis. We meet with the entire subcontractor pool as an owner. We do that on a monthly basis. So there's a lot of those kind of communications that happen to make sure that we're not getting out of alignment. Because that's where you really start to have the misses, when people lose track of what's important and what's coming at them. Roger, I don't know if you want to add to how that translates down to the factory level.
What Mike said is absolutely correct. But I think what's important to recognize is that one of the things when you're moving so fast is that you have to find a way to prioritize everything in the right order. I'm not, I know everybody's smiling because that's a big ask. Like, is it most important that we get economies of scale and we build the buildings fast so they're all the same? Or is it most important that you have a variety of, solutions for the different users? Or is it most important that we get in, on site at exactly the date we need it? Or is it, and how do you tease out how to prioritize them is the big opportunity and the very complicated task. And you do that right. And, it's like putting your golf ball on the tee correctly and, and positioning yourself in the right place and taking a swing. Like, that's the most important thing. And then after that, things aren't so hard to tweak, but that's a big ask. And you always have to weigh, because things are going to clash with each other. So you always have to weigh, like, here's the opportunities, here's the costs. What are we doing based on this conflict of decisions? And so that's a biggie. It's a big ask.
Cherise, at the risk of over answering, you started by saying, multiple cooks in the kitchen, right? Let me give you a different picture. Multiple kitchens is where we began. And then it's really a matter of inviting people into your kitchen and then going to we had to do some rapid learning about the way different people not just work, but just fundamentally think about the process. And the reason we had to do that is we're doing things that would be a strain for a private developer to undertake. And we're doing it then with an institutional client, then within all the requirements of the CSU system, one of which we touched on, which is the Office of Fire Safety, the jurisdiction, one of the jurisdictions having authority. But when you put all that together, you've got people in their individual kitchens, and we needed to figure out how to get them out of their individual kitchens and into a room and in a space. But then we realized that wasn't enough. We need to invite them into our different areas of deep knowledge and expertise. And then once we understood more about what was in their head, then I feel like we really were able to start moving forward. That took some time. And yeah, it was the classic, we're building the plane as we fly the plane because of the schedule that we were, the need for beds, we were moving very quickly.
It takes me back to Mike's answer at the very beginning of our icebreaker question, in that maybe teams in this business could be doing better as teams. And this sounds like a shining example of how you can get outside of that box and do something different. What I would hope you will all do when this project is done is, number one, come back and tell me more about it after it's all built. But number two, I hope you write a case study that other people can learn from, because probably save a lot of people a lot of gray hair when they try to take it on. So I close every episode with two questions, one being a more broad industry question, and then the closing question I make everybody answer just because it amuses me. And so for the industry question, I would like to ask all three of you, what would you say are some of the bigger issues or biggest issues that public agencies are facing right now in trying to do a new building of any kind, whether it's modular or stick built? What are the biggest challenges in the public realm?
I always call it the owner's dilemma, and that's a book that a friend of mine, Barbara Bryson, wrote that I would highly recommend. But it is that the things that we as public owners need i- is more efficient processes, and we have to address the cost of construction. We have a housing crisis because construction costs so much. Our infrastructure is failing because construction costs so much. I mean, these are the cost is preventing us from taking care of our built environment the way we need to. And and I always, but the irony is that we, the public owners especially, have created the system that costs so much. And by that I mean the contracts, all of the requirements, the way we pass risk down to our supposed partners, the way they then pass risk down to others, the checks and balances that we put in place that, seemingly for all good purposes, are all of the things that drive the cost of construction up. And there's quite a bit of research done, and these are, like tens of percentage points of cost that we're adding to the cost just because we have these rigorous processes. And it's so the dilemma is we want lower cost construction, but then the market can't deliver it because we're not really asking for it. And the market has evolved to get used to the processes that we ask. David's description of the design process and the feedback loop that he gets is a perfect example of that, right? He's used to that. We can say, no, that's not the process we're going to do. But that's how his whole firm is set up, right? So they still do that. And so the same is true on the construction side. So we've created our, like I said, we're our own worst enemy. We've created this system that inflates the cost, and we have to start deconstructing that pretty quickly.
I want to send you chocolates or something for giving that answer. Because if I had to pick one thing over all my years of doing public work, is every time I worked for a new public client, it was basically rewriting all of our documents to accommodate that client. And that's just in the same state. You go to another state and you are literally having to recreate the wheel for every public client. And I've always struggled with that. Like, how does this make sense? So I agree with you there. From a design standpoint, David, what would you say for public work is, the bigger challenges of facing in today's current world and environment?
Yeah, I think it goes along the lines of what Mike was saying, um, in terms of wanting, let's say, lower cost or innovation or something new, but not being willing to change your processes and thinking that we're going to hire people who've done this or have this skill set, and somehow by hiring the team or the consultants, we're done. And now if we can, via expectations, we will have some new outcome. And I, it's much harder work. And you really do have to fundamentally change the way you work to be able to arrive at a different outcome. And so, I tend to find that what we're generally see is band-aids or little what end up being novelty rather than innovation, because that's the extent to which uh, our risk tolerance or our ability to change the way we work is. And I think we're on the precipice of as an industry of needing for our existence, for our success, to truly innovate and move beyond what I'll call sort of um, accumulation of novelties in place of true innovation. So, and the public sector needs to lead the way. I'll say one more thing. I don't think it's the sort of thing where the public sector waits for the private sector to do something and then adopt it. Some of what we're need to do in our industry needs the backing the support, the leadership of big public institutions for us to make these changes. I don't think it's going to happen from a development or a private sector, personally.
I couldn't agree more. And I am starting to see that a little bit. And funny thing is, most of those projects are coming out of California where they're starting to break out of the mold. How about you, Roger?
So I will look at the same question a little bit differently, but along the same lines. So to me, there's two major areas that I think, and Mike mentioned one of them, which is that public procurement, et cetera, does need adjustment, as does permitting. We've already mentioned some of those constraints, et cetera, and that requires a good redesign. And, CalPoly has tried to do that sort of using this system. And I think that is incumbent if you're going to get any efficiency to deal with the housing crisis specifically. And then on the other side um, is speed and capacity constraints. So velocity and capacity are two things that the industry, after the mortgage crisis of 2007, sort of shrunk at a risk basis. And it has never, and it probably will never, I don't know, I hope it does, but it will never catch up. So you have this capacity and velocity constraints on one side, and then you have, even if you could get it moving fast enough, you have to get it approved and you have to get it designed and procured appropriately. So those are the places we can collectively improve, public private, and without that, it's going to be hard to move the needle. That's sort of the way I look at it.
So, final question. Every guest who has ever been on this podcast has had to answer this question. So, you gentlemen are not getting out of it. So, I like to believe that we all hope, no matter who we are or what industry we work in, we all hope to leave some kind of contribution to make the world a better place. So, for each of you, personal or professional, it does not have to be related to architecture or construction. What do you hope your impact will be? Nice, easy question to end the day. Who's brave enough to go first?
I'll go.
Okay.
We have a little saying in the firm that we want our projects to do more than solve a problem or just address a need. What we're really striving to do is create a memorable place that helps foster community, sense of belonging, and when we're doing the very best of our work, I would say it even inspires people. And I think that's really what we're trying to do in terms of making the world better is we still need beautiful things. We need things that inspire us and make us think twice and look at the way the light is hitting that. And, oh, that was unexpected, that moment of levity or surprise. And I think as we become more and more of a place with AI, with predictive outcomes and a little bit of an answer society where we, when there's a question, we pick this thing up and ask it what the answer is, that these other more sort of subjective, nuanced elements are really important aspects to have in our life. And I think that is part of leaving some breadcrumbs for others to find and be inspired.
Roger, how about you?
So I have been on a journey and quest simultaneously for the past 15 or so years to change the way that we create the built environment specifically for housing. And my hope is that the legacy is that the solution that I have been pushing for and towards has an effect on the housing needs and capacity for this country and other places, not only this country, but it's an insatiable need, at least for the near future, and trying to chip away at capacity and velocity is really with something that is high quality, that doesn't look modular the way you said, so that it is high quality housing for the appropriate use, and taking advantage of the economies of scale that industrialization offers.
And it's so needed in so many different areas of our population. Mike, how are you going to change the world? What's your impact going to be?
I think this is why we get along so well, is we all are kind of, revolutionaries in some ways. Like there's a belief that the built environment really matters, right? And I think we all share that. And so my hope is that it's not just us. My hope is that we have a lot more people thinking about process and how we build these things in a very different way, in a very open-minded way, that we can start to get over this this position that we're in now, right? Which is the built environment is just costing too much, and it is the solution to many of the problems that we're having as a culture right now. Is if we can just build our way and find more efficient ways to build it, we can solve a lot of the problems: sustainability, housing, infrastructure. You can the list goes on and on, right? But we can't do it unless we have people that are willing to really rethink the process. And that's my hope. And so CalPoly is one of the best architecture schools in the country. It's highly sought after graduates. We spend a lot of time over there talking about this project and trying to get the students to say, no, there are different ways to do things, and we really want you to see this and be exposed to this. This is right in your backyard. So you really should take stock in this. And so we're, it's more of a kind of mission to advocate much more broadly than just the success of the project itself.
And an important one, because I couldn't agree with you more. Gentlemen, this pleasure. Let me do this again. Gentlemen, this conversation has been an absolute pleasure. Seriously, I could sit here for the next 4 or 5 hours asking you questions. I had so many popping into my head. I hope you'll consider coming back when it's built and maybe having a little case study conversation about the project and how everything went and the lessons learned to share with the rest of us who could stand learning from that. But I so appreciate your time in joining me today, and I can't wait to share this episode.
Thank you, Cherise.
Thank you.
Thank you so much.
Thank you, Cherise.